Hello, today we're going to be learning how to convert between our quadratic forms. So throughout this unit, we've learned three different forms of the quadratic: the standard form, the vertex form, and the factored form. We know how to go from the factored form to standard form by just FOILing it out, and we know how to go from vertex form to standard form again by FOILing it out. But we do not know how to go from standard form to vertex form. We haven't learned that yet, and that's what today is all about. So real quick, here are all of our forms. All right, the first form here, y equals ax squared plus bx plus c. That is our standard form. When we have it as y equals a times the quantity x minus h squared plus k, that's our vertex form. It tells us what our vertex is just by looking at it. And when it's broken up to the parentheses, that is our factored form. So today I'm going to teach you both ways. I'm going to teach you how to go from from standard form to vertex form. And I'm going to teach you how to go from factored form to standard form. So I'm going to teach you a couple different things today. So the first one, we're going to convert the quadratic y equals 3x squared plus 12x plus 11 into vertex form. So like we've been doing, I have some steps here and I have the process. So go ahead and pause for me and write down all these steps, and then we'll continue from there. All right, hopefully you've paused the video and you've written those down. So the steps are isolate the x's. We want the x's all by themselves. Number two is we want to factor out any a value. And what we're going to do is we're actually going to be using the same steps that we did for the completing the squares. So we're going to add b divided by 2 squared to both sides. And from there, we're just going to simplify and solve for y. So unlike all the other problems we do, usually it equals 0. All right, but we're going to keep both the x and the y value because the whole point is we want to convert it to vertex form, which if you look at vertex form, it still has a y and it still has an x value and numbers surrounding them. So we want to keep those two variables intact. So the first thing it said, isolate the x's. So if I'm looking at 3x squared plus 12x plus 11, I'm going to subtract that 11 over. So about y minus 11 equals 3x squared plus 12x. Okay, step one, done. We isolated the x's. Step two, we want to factor out the a value. If I'm looking at this, my a value is 3, so I'm going to factor that a value out. Here's where we do our completing the square. We're going to add b divided by 2 to both sides. Now, remember, you're doing b divided by 2, and you have to multiply by that a value on both sides as well. So over here, I've got y minus 11 plus, we've got our a value of 3, and then our b divided by 2 squared value. Running out of room, sorry guys, a little messy. Let's do some simplifying. 4 divided by 2 is 2. 2 squared is 4. So I've got y minus 11 plus 3 times 4 equals 3 times. So I've got y minus 11. 3 times 4 is 12. All right, negative 11 plus 12 is 1, so we've got y plus 1 equals 3 times. And we know we can factor this. Remember, this always becomes x something squared. You take your b value divided by 2. Well, positive 4 divided by 2 is 2, so it's x plus 2. To get this into vertex form, instead of solve for y, so the only thing standing in our way for getting y by itself is that plus 1, so we're going to subtract 1 over. And we have officially converted it to vertex form now. Just a quick refresher, if we haven't done this in a while. Let's talk about the transformations, because we haven't really gone over those in quite some time. All right, from looking at this, that 3, that tells me it's a vertical stretch, because it is greater than 1 of 3. That plus 2 tells me we're going to the left 2 for my vertex. And that negative 1 tells me we're going down 1 for my vertex. There is no reflection because there's no negative out in front. second type of problem today is we're going to be converting standard form, and it's going to give us the roots, and we're going to be working backwards here. So our goal is to get it into standard form. And it has the roots 3 plus or minus 2i. So what we're going to do is we're going to be working backwards. So I'm going to have you take a little flashback real quick. We did problems kind of like this. If I gave you x equals 3 as a root, what did that look like as a parenthesis if we were to unsolve for x? If I unsolve for x, I'm going to subtract 3 from both sides. So I get x minus 3 equals 0. So that's what that parenthesis looked like. What would x equals negative 2 look like as a parenthesis? Add it over. I get x plus 2. What would x equals 4/5 look like? To get rid of that 4/5, we multiply by 5 on both sides first. So I've got 5x equals 4. I subtract that 4 over, so I get 5x minus 4 as my parenthesis. So what we're going to do is we're going to do that same idea. We're just going to kind of work backwards with a little bit more information because we have complex numbers. Okay, so there's our little flashback. So I have x equals 3 plus or minus 2i. So our goal is to move everything over. All right, so I'm going to move that 3 over first. How do I get that 3 over there? I subtract it. So I've got x minus 3 equals plus or minus 2i. Whenever we see that plus or minus, think about what operation gave us that. Usually when we take the square root of something, we get that plus or minus. So to get rid of that, we're going to do the opposite of square rooting. The opposite of square rooting is squaring both sides. So we're going to square both sides. So this would become x minus 3 times x minus 3. And this would become 2i times 2i. Over here, we get x squared minus 3x plus 9. And over here, we get 4i squared. If I combine like terms, I get x squared x squared minus 6x plus 9 equals, let's think, I know what I squared is. Remember, with our complex numbers, I squared is negative 1. So it actually equals negative 4 over there. To get it all the way to standard form, it has to equal 0, so I'm going to add that 4 over, so I get x squared minus 6x plus 13. And that would be my final solution.